Welcome back, Algebra Express. So we are in Marecek 3.5. We are going to start talking about relations and functions in this section. And so the first thing they jump into here is a relation diagram. So I've talked a little bit about set theory. So set theory is a topic within logic. And so if we apply set theory here, this is the set of states. This is a set of median incomes, and then these arrows are a sort of relation that goes from this set to this set. And so I think we just jump into these questions. It looks like they cited their sources here with the U.S. Census. And so this is the median income and thousands for a four-person family by state. Okay, so the first thing they ask is, what is the median income in Illinois? And so if we're looking at Illinois, we're following this arrow down to the number 72, and they're talking about 72,000. And so the next one says, in what state or states is the median income 72,000? So we look over here at 72, we might notice that there are 3 arrows going to it. So what you should give me is a total of 3 states here, and they should be, what are they, Alaska? We got Colorado and Illinois. And so maybe a quick statement on what median is. So median is also known as like the 50th percentile, meaning that half the people make less, half the people make more, which is not the same thing as maybe like if you take the mean of it. So the mean would be the arithmetic average. So we use these words like average, and in statistics you might hear the word like central tendency. We use like things like mean and median to get at like what the average sort of person makes or what they do. And so one reason they use median over mean is because of sort of the way that wealth is distributed. You have like people that make a whole lot of money that maybe don't represent like probably what the average person is making, right? And if we throw them in there, it's going to make the average income look higher than what it probably really is. Those people would be called outliers is the word that they would use to describe those sorts of people. So there'd be outliers on the far upper end of that thing for sure. Okay. So a lot of times you'll see median, and then the reason why you see median is like I said, because it's because of that issue of wealth distribution is going to make things look is not going to be an accurate representation of the average person. So 3 says the relation above could also be described as a set of ordered pairs. So we're looking at this thing, we're trying to make ordered pairs. And so far we've made ordered pairs out of numbers. I think one of the things they're trying to get at here is when we have sets, they don't always have to be both numbers, right? We can have Alabama has 55. I'm talking about a set of ordered pairs. Alabama's 55, Indiana's. Probably not. Massachusetts. on the end, close it. I'm gonna put commas everywhere I should have, hopefully. Okay. Whew. So this is a little bit, a few words you might have to write. But all we're doing is we're looking at this thing, and maybe I should mark it up. I'm looking at this as kind of sort of like my x quantities, and this is kind of sort of like my y quantities. And I'm just looking at these as an ordered pair that look like kind of like x comma y. Okay. And so what I think they're really trying to get at here with these first 4 questions is like the structure of this thing, right? This is they're about to define it. The domain is a set of all x values. The range is a set of all y values. So what they're trying to get at here is that these things are like my domain. There's some sort of relation that maps them onto my range. And so the last thing we need to talk about is domain and range here. So my domain, and so this is kind of probably the weird thing that they're trying to also get at, is my domain can be words. And I'm going to abbreviate it because I'm running out of room. Alabama, Indiana, Alaska, Colorado, Illinois, and Massachusetts. And my range, 55. There are 4 numbers in my range. So maybe also another observation you might be making is there are more items in my domain than in my range. So some of these guys are going to end up getting doubled up when they come here, right? Okay. So most of the time, they're not going to give you a relation with these relation diagrams. We're going to do it with probably like ordered pairs or through function notation, which we'll go over in a minute. Okay. But they are a good visual representation of what's happening. So they do help out. Okay, so we're there. Okay, so now we're talking about the domain and range here. So my domain, they just defined it on the previous page. This should be all my x values. So if you want to look along here at the x-axis, and what I will typically do is go from least to greatest, left to right. It's just typically easier to do that. The first x I run across here is -4. The next one I run across is right here at a -2. And I look here, and which number is this? So I know it looks, I think the thing that most people are going to do is they're going to look at this, and they're going to look across, and they're going to look at this 2, but that's on the y-axis. We want to keep it on the x-axis, so we're keep coming down here to the x-axis. This is a -1. This is a 2 and a 3. So you can come across the x-axis, so you can put these numbers down. This is one way you can do it. We can go left to right, we can go bottom to top. Okay, and so now we're looking, we have a -3, we have a -2, we have a -1 right here, we have 2 and 3. This is one way you could do it. Another way you can do it is you could actually list out all these ordered pairs. So -4, 3 is an ordered pair. -2, -1. I'm not going to list them all out, but this is another way you could do it. You could pick off your x's here. -4, -2 would be from the x's. -1 and 3 would be going into my y's. So you could list out the ordered pairs and pick out your x's, pick out your y's. If they give you a graph, I don't know. I think I would just go with this approach. If I'm doing my x's, I would go left to right, and I would look at the x-axis to pick off the numbers. This is a -4 on the x-axis, right? And I'm just coming across here with the x-axis, only looking at the x-axis when I'm doing my domain. I'm coming across here with my y-axis when I do my range, only looking at my y-axis. So that's the way I would personally do it. This is also another valid way to do it, right? Although I feel like that's more complicated. That's the way I feel personally. Okay. So the next thing is we're going to talk about a function. We talked about relations. So a function is a specific type of relation. So a relation relates two sets. We have a set of objects here. We have a set of objects there. I'm not sure there's a more simple word than relate, right? And so it tells us how the two objects connect. Here we're going to talk about a function. So how do they define it? A relation in which each input has exactly one output is called a function. That is a fair way to define a function. I'm not sure that's the way I would go about trying to figure out if something is a function. So if we want to figure out if something is a function, I think it's probably better to ask, does it break the function definition? And if each input, what does it say? Each input has exactly one output. So something that would break that is that you have one input. But you have one input, and you have multiple outputs, more than one output. Going at this again. So our inputs are like our x variables. So if you have the same x, but you have more than one y, you have multiple or different y. Multiple. So we want to see if it breaks the definition of a function. And this is the way that it's going to end up breaking it. If we have one input, more than one output, or if we have the same x and we have multiple y's. So this is going to kind of change a little bit depending on what sort of form we're looking at, whether it's in like a diagram like this or whether it's in ordered pairs. But we're looking for the same x, a repeated x, with different y's. Okay, so already this guy, let me grab the previous page. If we look at the way we wrote the ordered pairs, I think it's pretty obvious if we look at these x's, none of these x's ever repeat. We have a different state for each one. So this one, none of these x's, none of these domain values ever repeat. And so this one, I can tell right away, is a function. if I look at each of my states, it is going to give me exactly one median income. And so that's following their definition. Okay. So for this one, I want to write this out as an ordered pair. If I look at and you could probably guess if this is the example of a function, this one is going to be. And let's talk a little bit about why. So a little bit about why is because we have this input. So 4 is going to give me 1.6. 4 here is okay. It's really this thing right here, right? We have 6 and we have 6. And if we look at it here, we have 2 arrows, meaning that 6 can either go to 2.4 or 6 can go to 3. If we look at it as a set of ordered pairs, we're going to notice that we have the same x, but the y quantities are different. And so this is telling me right here, it is breaking the definition of a function. And so it breaks the definition of a function there. It also breaks the definition of a function with this number as well. So it is definitely not a function. So we're talking about one input with multiple outputs. So this 6 can either give me a 2.4 or it can give me a 3. And so I'm hoping like this makes a little sense on why we want something that is a function now, right? If I put in like a state of Alabama, I want one median income to come out of that thing. I want one number to come out of there. I don't want to ask what is the median income of Colorado, and you're like, I don't know, 55 or 72. Like that's a big difference, right? That's not a very efficient way to get at that, right? And so we want something when we put in a number, when we put in an input, it is going to give us a unique output. Number of cylinders versus engine size, right? I guess there are some things that don't follow a relation of, or the sort of relation of function is, right? That would be one of them. Okay. And so here they're defining what a function is. The next page, we're going to go into the notation that we use for a function. Okay. And so sometimes, I don't know, sometimes they draw the little machine, right? The next, it's going into the machine. It's getting processed by like our f function, and it is going to spit out. Ooh, horribly, John can't see everything. And it is going to come out as like an f of x or a y value, right? Zoom out on this a little bit. It's a horrible drawing. I don't know why you really need to see all of it. Here we go. Make this into more of a tube. Okay, so we got our little machine. We're going to plug in an x. It's going to spit out another value called our f of x or our y value. So this is just getting at the sort of notation that we're going to use for functions. Let me readjust. let's go a little bit. A little bit. Okay. Okay. So this thing represents our function, this thing represents our input, and this thing represents our output. So this is the general form of our function notation. And so what they're saying is, now they're giving us an example. This is our function. So when we plug an x into our function f, we're going to get out a y value. Okay. And so this is going back to the first page. And so what they're asking is, when we take the median income of Indiana, what number are we going to get? And going back to this page, I believe Indiana, no, it wasn't. Indiana was going to, I believe, 65. Maybe you're asking, like, why didn't I put 65,000? Well, the y values that they give us are not with the thousands on there, right? If we interpret it and give them back English, we should give them probably the thousands. Here they're asking for the y values, they're asking just for the number. And so here they're really asking just for the 65. Number 10, we're not talking about number 10 anymore. No, I don't really know. I don't know what happened to their spacing. It's not there, so let's not talk about it. Number 11. The median income, when it is the median income, they want to know x, which is our input, to get to 72. So this is another way of saying, like, which countries had a median income of 72,000, right? This is another way of asking it. So this is if we plug Indiana into the median income, we're going to get a number of 65. And this is like, well, what state would we need to plug in to get 72? So there are a few values that our x could be. They were three different states. 3 different states had that median income. They were Alaska, Colorado, and Illinois. Okay. So number 11. Okay, number 12. So this, they're just trying to get at notation. They are just giving you that same problem. They're giving you the same problem because you're familiar with it already, hopefully. You know a little bit about what that diagram is saying on the front page. And so they're just trying to get this f of x equals y sort of notation in there, right? This is my input, this is my function, this is my output. So this is my input, this is my function, and this is the output, right? So when I plug a t into my h function, I'm going to get something crazy, some kind of crazy number. What is it telling me? So the function h of t equals a negative 16t squared plus 64t represents the height h of a model rocket in feet t seconds after launch. Okay. So this function is giving me the height after t seconds. So when I plug in my t value, this should give me a height in feet, is what it says. And so now they want us to evaluate h of 2. So let's look at this, because they definitely don't give us enough room on here. This is I think the first time they give us this sort of problem. This is the first time we look at this equation. Like this equation, they'll throw it out at you a few times throughout the semester, so be ready to see it again. It could be a rocket, it could be a rock, it could be a football. It's a projectile motion of some sort is what it's doing, right? So if we want to do h of 2, let's do part A. Part A. I'm going to plug in, this is my function. Everywhere there's a t, we're going to plug in a 2. So this is going to take spot of t. We're going to plug in 2 here. We're going to plug in 2. Okay. I'm doing a bit of work here. This side, I guess I can use 2. Minus 16 times 4 is a minus what, 64. 64. And so they ask us the first thing to do is find h of 2. And then they want us to interpret it. Okay. So what does this mean? So they give us this function. It represents height of the model rocket in feet after t seconds after launch. So this means after 2 seconds, the rocket is what, 64 feet in the air. So that answers that question. There is something that like students really try to do. We have gone through this, and it's a valid thing to look at. You see it, and it's actually like it's when we use parentheses for too many things. A lot of students will see this, and they'll say h2 equals 64. They'll go, I'm solving for h. H equals 30. So this, I want to say, don't do this, right? Don't, no. This is a function notation. This means when I plug in 2 into my function, I'm going to get 64. This is the correct interpretation of what this means, right? This is not multiplication. So do not look at this as multiplication. It is not multiplication. We are plugging things in, is what we are doing. That's what I did up here. I plug things in. I plugged in the 2 to my h function, is what this is telling me. I plugged in the 2 to my h function means after 2 seconds, it was that tall in the air. So don't look at that as multiplication. Don't do it. So that is the correct interpretation. So let's look at the next one. They want us to find h of 4. H of t is minus 16 t squared. Okay, so h of 4 looks like take minus 16 and plug in plus 64. Plug in. Okay, so this looks like minus 16 times 16. 64 times 4 is going to give me 256. Minus 256 plus 256. And this is giving me, move it up just a little bit. This is giving me a big old goose egg is what it's giving me. H of 4 is going to be 0. So when I plug in 4, I'm getting 0. So what does this 0 mean? This means 4 seconds. This means 0, what, feet? So there's a few ways you could say this. I guess you could say after 4 seconds, you say the rocket is 0 feet high after 4 seconds. This is what I would say personally. The rocket hits the ground. The rocket goes up, the rocket comes down, the rocket hits the ground. So at 4 seconds, it is at 0 feet. That means it is on the ground. It hits the ground exactly at 4 seconds, right? A little bit about what this thing might look like. I know we're not on that section yet, but we talked about like a lot of life kind of happens in the first quadrant. I think that's come up already. If we look at this equation, this h of t equals a minus 16 t squared plus 64t. Okay, that is a quadratic. It looks like a negative quadratic, so it is an inverted parabola. So it looks something like this if you wanted a sort of graphical representation. So there is more to this parabola. We're just not thinking about it, right? We're just kind of cutting this thing off. And here at 0 seconds is going to be at 0 feet. Over here at what, 4 seconds, it is going to hit the ground. It's going to go up, it's going to come down, is what this says. And if you know things about parabolas, we can actually come out here in the middle and say at 2 seconds, that's actually where it's going to be at its peak. Not expecting y'all to like deduce all that from this first example, right? But it's coming up, and we will be able to do that eventually, right? So at 2 seconds, we get what, a height? I think we found that height already, right? That was the thing I just threw down here. 64, I believe, is how high this thing is. And we talked a little bit about like domain and range. So if we wanted to know like the x values and the y values, there is something that when we get to word problems, we're going to talk about like implied domain. We're going to use this word implied. And so if we look at that here, the implied domain would be everything from what, 0 to 4. And what we really mean with implied is like there's some kind of restrictions that reality is putting on them, right? And so our implied domain would be like 0 to 4. Our implied range would be from what, 0 to 64 is as tall as this thing's going to get. And so it's implied because it doesn't make a lot of sense to talk about like negative time. It doesn't make a lot of sense to talk about what happened to the rocket after it hit the ground. Well, it's not a lot of interesting things, right? Most of the interesting things was when it went up and came down. Okay. So back to the worksheet. We did the rocket. Now they want us to do these. Okay. So how my f of x function equals minus 5x plus 1. And this first thing says f of 5 minus f of 3. So if you want to take f of 5 is going to look like plugging in a 5 everywhere there's an x. So minus 5 times 5 plus 1. And if I want to do f of 3, that's taking the same function and plugging in a 3 everywhere there's an x. So we could do these separately. We could figure out their solution. This is minus 25 plus 1, I believe it's minus 24, minus 15, minus 14. We could do these separately, and we could do f of 5 minus f of 3. And if we do f of 5 minus f of 3, this thing is really a minus 24. And we're going to subtract a minus 14. Okay, so it's really what? Minus 10. So you can do them separately. If you want to do them like all in one time, we can also do that. F of 5 minus f of 3. F of 5 is what happens if we plug in what? 5 into our equation of minus 5x plus 1. Subtract. You can do them all at once if you want. But my suggestion here is if you're doing them all at once, put like some parentheses around the thing that you're plugging in. Put some parentheses around the f of 5. Put some parentheses around this, because thing here, subtraction is not commutative, right? And we're going to have to do some distribution here. So buyer beware on that. You should still get the same thing. This is minus 25 plus 1. This is minus plus 1. Bracket's becoming curvy, but it's there. Okay, so this is still minus 24 minus a minus 15 minus 10. So either way, you should get the same number. Ooh, it's getting warm in here. Doing some hard math, I guess. Crunching some heavy numbers. Okay, so that is 13A. 13B, we're going to do f of x plus 3. So my f of x minus 5x. Okay. So if I want to take this function, I want to plug in x plus 3 everywhere there is an x. So what does that look like? That looks like minus 5. I'm plugging it in. Anytime I plug something in, I'm almost always going to put some parentheses around this thing. So I'm putting in parentheses. I don't want to put x. I want to put x plus 3. I'm putting in x plus 3, and I'm adding 1. So you see this. If you did this, you did the large part of this problem. That's the largest sort of step. Like if you can see this step, that's what this problem is mostly about. The rest of it is just some normal everyday algebra like we've been doing so far. The new thing is this thing right here. Can you see why I'm plugging in x plus 3 into this spot right here? It's this thing. Let me grab a pen. My x here becomes an x plus 3. My x here becomes x plus 3 here. This is what I'm doing. Next thing, I'm going to do some minus 5x minus 5x. So a little bit of distribution and combining like terms. This is saying f of. I'm going to come back and put that. I can say f of x plus 3 is minus 5x minus 14. Okay. Okay, so another thing, I'm going to ask this question, I'm going to let you check it, I think. F of 5 minus f of 3 Can I do f of 2 for that one for part A? That'd be the same. Okay. So it is not going to be the same. Don't do it. And a part of that is if the reason why I did that was because if you look at these as coefficients, if you do look at this as multiplication, which you're not supposed to do, right? Then you could maybe get to there. But then if we check it, right, if we plug in 2 to this, I believe f of 2, when I calculated it, it gave me a -9. And so that was not the -10 that this thing was. This thing was equal to -10, right? And so that's another indicator that this is not multiplication. When we're plugging things into this function, things behave differently, right? This is an input, and this is an output. This is an input, this is an input. We need to know their outputs, and then we calculate their outputs. So we're crunching like y values there, right? Okay. This is the student activity. So hopefully you're making an honest attempt at these ones. So each day, 5 new puzzles are downloaded into Ken's account. The function n of t equals 43 plus 5t represents the number of puzzles downloaded t days from today. Find n of t minus 1. So that calculates the number of puzzles Ken will have the day before t. Okay. So I guess they could have maybe found something a little more relevant than just like downloading puzzles or something. I don't know. Maybe not the most interesting thing, but it's there. We have this thing. This gets used quite a lot. If you want to do like recursive functions and things of that nature, you'll be using certain things like this. So they do get used quite a bit. Even though the example here may not be the best, it still works for what we need to do, right? If we have n of t and this represents something, it represents the number of puzzles after t days. We want to find n of t minus 1. So if n of t is 43 plus 5t, what is n of t minus 1? So what have we done to go from n of t to n of t minus 1? Well, everywhere there's a t, we're going to have to plug in a t minus 1. So this is 43 plus 5. And now instead of t, I'm going to plug in a t minus 1. And I hope your eyes are hurting. I hope there's something you do every time. Every time, let me tell you. Let me tell you, every time you plug something in, always put some parentheses around that thing. So now we're going to simplify this a little bit. 43 plus 5t minus 5. So what is this? 43 minus 5 is 30. 5t, right up in here. 8 plus 5t is what you're looking for. Okay, now they're giving us a relation. And they want to know, is that relation a function? So if it's a function, go ahead and write yes. If it's not a function, what I want you to do, I want you to circle the first thing that shows you it's not a function. And so if I was coming along here, I'm probably giving you too many hints, but I would say no. And the first thing I would circle is that thing and that thing, right? Because it both has a x coordinate of 2, but it definitely has different outputs, different y coordinates. So it breaks it there. It also breaks it where? Here and here, right? So it breaks it twice. Same x, different y. Same input, different outputs. We want each input to give a unique output. It did not happen. So my domain here, so typically my domain, I want to go to least to greatest. So I believe we go 0 to 4. And it repeats 2 and 0. So you might want to put 2 and 0 in there more than once. You don't have to. We only really need to account for it once. And I think I probably already did that without saying it explicitly, right? But if there's repeating values, you don't have to put them in there multiple times. Least to greatest, put them in there. Now we're going in the y's. I have 0, 4, 8, 12, and 16. 0, 4, 8, 12, and 16. So if we just look at the size of these sets, it's probably going to be obvious like these things are going to have to double up to get here, right? It's a smaller set. So that's also probably another indicator it's not a function, right? Okay, so I believe that's the last problem on this, on these lecture notes. So I will see you all in class soon, hopefully. All right, take care.